So I'm so happy today to have John M. Phillips from the King County Wastewater Treatment Division in Washington State here. I grew up in Kirkland, Washington, so I can relate to the weather that you are suffering with on a daily basis in the middle of January. John is currently the Combined Sewer Overflow Manager. He's worked there and has worked the last 9 years on the Combined Sewer Overflow Control Program. He developed and is managing the Green Stormwater Infrastructure and Climate Change Adaptation programs, and his expertise has been part of the IPCC and National Climate Assessment reports. I'm so happy to have John speak to us today about his experience with the Green Stormwater Infrastructure and how to control combined sewer overflows, a topic that's very important in the rainy Pacific Northwest. And again, thanks for joining us, everybody, today. We hoped to have John last, I think it was October, and he had a schedule conflict, so I grabbed him for our first webinar of 2018, and I'm so happy that he was available. So you can go ahead and share your screen, John, and make sure you unmute yourself, and I will mute myself and go to presentation mode. You got it? Awesome.
Great. I'm just going to assume everybody can hear me.
Yes, we can hear you. We can hear you great.
So here I am in the Pacific Northwest, and as most people think, it rains a lot here, except for today. I'm gonna let you in on a little secret. It's been warm and sunny the last 2 days here in Seattle. Just to give you a sense of where we are, I did put together a slide because I watched everybody say where they were from. I thought, you know, it might be good just to kind of orient people. We're up here in the Pacific Northwest of the United States, unique weather conditions. Now, everybody says it rains a lot, but really, we get heavy rains only a few times a year where it's a downpour. What we do get is a lot of darkness and a lot of drizzle. So managing a combined sewer system with unexpected peak event storms is a challenge. And one of the ways we wanted to address that challenge is to look at the use of green stormwater infrastructure. So the kind of stuff people have been using to manage stormwater for several decades, start implementing that within our combined sewer overflow program. Both King County and the city of Seattle operate a combined sewer system within the city of Seattle. And that's just that little small dot on the map here around Puget Sound. So what were we doing? The CSO program decided to use green stormwater infrastructure in 2 different distinct water areas, which I'll show on the next map. Our lower Duwamish waterway and then the Ship Canal, which was actually kind of dividing the city in half. We wanted to work closely with the city of Seattle, and I'm going to give a shout out to the city of Seattle. So if anybody from the city of Seattle is listening, they did it for a lot longer than King County did it. And we were more than happy to start working with them and gain some of their experience on using green stormwater infrastructure, or GSI as we call it, learning it from their great program. At the same time, we both agencies decided to use green stormwater infrastructure in our combined sewer overflow program at the same time. So we were able to actually put a joint program together where we share a common contract, look at common goals. Now the one challenge was we were building this stormwater infrastructure on city roads. We were the county, they were the city, and a whole other department actually managed the roads from those who manage drainage and wastewater. We also had a joint, what we called the Rainwise program, which is a voluntary private rain garden and rainwater harvesting program where we actually provide incentives for people to install green stormwater infrastructure. So here's the city of Seattle, kind of broken up as the way we look at it here in the combined sewer world, which is a lot of different types of plumbing. We have big pipes that carry combined sewer. So that's the area where there's one pipe for both the stormwater and one pipe for sanitary sewage. Those pipes were built even starting back in the 1890s and probably came out of preference back in the late 1940s. So we have a legacy of having these combined sewer systems throughout the city of Seattle, which is highlighted in the green here. We also have places where someone went out and actually separated that. So they took the drainage from roads and streets, put that in a pipe, kept the houses and every sanitary sewage connected to the old combined sewer, and then we had less flow going into the combined sewer, but at the same time we still had houses, streets, and the sanitary, so it still went to the treatment plant. We called those partially separated. And then we have areas of the city, and the prime areas are the ones that are kind of hashed out here, which we kind of refer to as the creek basin, so major creeks going through the city. where it's fully separated, where there actually is a drainage system and a separate sanitary system for all the water. A lot of times there's some issues with that, where there's a lot of inflow and infiltration, where we have combined sewers, or reacts like a combined sewer system. Our regional combined sewer system is designed to carry about 2.25 times the average wet weather flow. So that's all the flow we see between October and May. We can carry about twice that in our pipe. So we have a lot of inline storage, which was kind of a challenge as we started looking at green stormwater infrastructure. So our philosophy is to lead with green. We would implement green stormwater infrastructure in places we found feasible, and the feasibility studies are extensive, where we look at geography, we look at street width, we look at the number of mature trees in a street, we look at how people park and use the street for parking. Because you can see in these two pictures, we actually do take up some parking spaces to get more of our GSI in place. And then on the right-hand side of your screen, you can see one of our bioretention cells, or rain gardens, in a heavy storm. And that one cell was filled. The successive cells down the street would fill up a little bit more as each one overflowed, and then eventually you get to a point where there wasn't any overflow from the rain gardens. This is the project that we first used extensively for GSI to control the CSO. It was called the Barton Project, which I'll get into a little bit of detail a little bit later as we go over some of the big projects we've done to control CSOs. Unique kind of construction, because when we lead with green, we usually end up with some gray. This is a 1 million gallon tank built right down on the waterfront. And this is kind of a place where we would look at reducing the size of that tank by doing some green stormwater infrastructure. We haven't got to a point where we've found we can control all of our CSOs with green stormwater infrastructure, but we can make these kind of difficult to site. You can notice there's a house right across the street. There's actually, where I'm standing taking this picture, condos just to the left of me, and then a nice waterfront park just off the screen towards the upper left-hand corner. So building these large facilities in these kind of very confined space in a very dense urban environment. So how does 1 gallon of CSO equate to a gallon of stormwater management? So what we have to do is we have to look at how much the rain gardens take up as far as stormwater. And if you look at this little picturesque equation, we have basically, we have a 1.5 million gallon tank we'd have to build. We could go out and build 7 acres of rain gardens, which equates to about 40 million gallons of stormwater entering the system. But going back, we don't really get 40 million gallons of CSO reduction. We get somewhere around 500,000 to 1 million gallons of stormwater reduction. So when we look at using how much rain garden we can fit in, for acres managed, how much stormwater is prevented from it, we actually have to model it in a way where we look at how much control volume, in other words, how much CSO is really being controlled by that. So that's something we have to go through. Although it is beneficial to get that stormwater out of our system, we still have enough capacity in the system to get quite a bit of stormwater to our regional treatment facilities. So bioretention was kind of the workhorse of what we were looking at for green stormwater infrastructure. And this again is a cell we just it's been in operation for about 4 years. This is what we call the inlet cell. So this cell's purpose really is to take in the flow from the streets, and it actually gets filled with sediment. That way there isn't sediment further down. So we kind of have one cell that we use for kind of treating. It's a lot like our wastewater treatment process, where we screen out the big stuff, and then later on we can treat. This series of cells actually leads to an underground injection well. So we actually have a series of bioretention cells with under drains that go to an underground injection well. That well usually goes down anywhere from 70 to 100 feet. The unique thing about building green stormwater infrastructure here in Seattle is Seattle was formed by a series of glaciers. So the reason we have kind of this really narrow band of land, the beautiful Puget Sound, is because glaciers kind of made it that way. In glaciers retreating, they compact the soil. So a lot of our high areas and areas where there's a lot of combined sewers, the soil has zero infiltration capacity. But dig down about 30, 40 feet, and you have this soil that's actually very amenable to infiltration. It has very high infiltration rates. We go from right on the surface of being at 0.3 inches an hour to getting down deep, we can go up to 100 inches an hour. So the soil changes here in Seattle because of our unique geography, but we've learned different ways to manage that. So these bioretention cells actually provide a level of treatment for that water goes into an injection well and then down into the groundwater. So we've been talking about this project for the CSO, one of our big ones we just we completed and just have monitored for about a year to make sure it's in compliance and is controlling the CSOs, is what we call our Barton Roadside Rain Garden project, which controlled the CSO that discharged in the Puget Sound. This was a series of cells. We did 15 blocks that looked similar to this, with the main cell, like we talked about, the first cell, a series of cells after that to control it, and then underground injection control to bring it down. This was in a high area. This actually was at an elevation, pretty high elevation. It wasn't down near sea level, and the soils here had some infiltration capacity, but wasn't very consistent. So when we did our feasibility, we said, what can we do to get the water down to where we can infiltrate a lot of water? In some of these cells, we actually see 100 inches an hour of infiltration. We do not get 100 inches of rain in an hour here in Seattle. I hope we never do. We're lucky to get a quarter to a half an inch an hour here in Seattle. If we got anything above an inch an hour or an inch and a half an hour, we were in serious flooding conditions. So while everybody says we're wet, we only have so much capacity to handle so much water. These cells do really well in all those storms. They also capture a lot of water that we used to just let go into the combined sewer system, go up to our treatment plant for treatment. So we've kind of reduced the amount of pumping and conveyance we have to do to get to the treatment system, to the treatment plant.
Hey, John, a couple people have told me that your microphone is so strong and powerful that they're having a hard time hearing you because there's some conversations going on in the background. So you probably don't have any control over that, but I just want to let folks know that we are noticing that, and I apologize. That's something I probably should have told John about, but we'll do the best we can, and you can always rewatch the webinar on our YouTube page if you missed something. So anyways, it's the joys of sharing an office, right?
Yeah, sorry about that.
No worries.
And I apologize to the audience. Obviously, there'll be time for questions, so if you wanted some follow-up, definitely send in your question. I'll see if I can say stuff loud enough about the conversations going on around me to maybe have people quiet down a little bit. So anyway, I'm going to go back a slide just to kind of finish my thoughts. This was a large project that we completed. It's been controlling the CSO now for about a year. We have compliance, but we also felt like there needed to be a little bit more in the city and the county to move forward with doing this, what we call the Rainwise program, which is an ability for people to incentivize and go out and build rain gardens and rainwater harvesting on their own property. And the program's been very successful as far as we've gotten a lot of participation. We've been doing a lot of outreach to different communities, and it's a great place for people to learn about the impacts of stormwater in the Seattle area. Lower left-hand corner was a location where we did what we call rainwater harvesting plus the rain garden. So there's a cistern and a rain garden. This was built with some community volunteers working under a contractor who could manage their work. And this was put in as actually a small community grocery store. And then the one on the right is what we call rainwater harvesting with cisterns. And they all get an incentive payback. It started at $3.50 per square foot managed, and now it's up to $4 per square foot managed. It's got a great website, the 700 million gallons. That's the website, 700milliongallons.org. You can learn all about the program, see what the specifications are, look at the incentive, look at the mapping systems we use to track where projects can be. That being said, we get a lot of participation. Seattle's a very diverse community, so we've done a lot of outreach to different cultures and different folks who have different needs for rainwater harvesting. So one of the things we also realized with the Green Stormwater Infrastructure use is this idea of co-benefits. I'm going to spend a little bit of time on co-benefits because it's kind of the thing when it's hard to put a dollar amount on. So when we're talking about reducing or being cost effective with GSI, some of the things we have to go back and look at, and I kind of mentioned earlier, is the energy savings and the water savings. When we're rainwater harvesting, a lot of water is being saved, and we've been doing some analysis to try to figure out how much potable water is being saved. The other thing is the energy savings, and that's the cost of us to pump this combined sewer, sometimes up to 10 or 15 miles to our regional treatment plants. And then once you get to the treatment plant, the amount of water you save, especially during a big storm event where our treatment plants are up in the range of almost 400 million gallons per day, which is quite, it's almost 4 times what it normally treats, where we can actually reduce some of those treatment costs. So the other things that we're getting into as co-benefits is this understanding of urban livability and people understanding what's going on with stormwater in the community, which we call the eco-literacy. Urban livability, we've been doing some work and some research with the University of Washington and National Forest Service on the idea that if we build green stormwater infrastructure, if we make communities have more green space, does it increase the amount of people that are out using sidewalks and moving from place to place? And if we're connecting key areas like parks and schools, are people more apt to move along those corridors where there's green infrastructure? We've been studying that for a couple of years and have a national expert on that, Kathy Wolf, who works here at the University of Washington, which we're lucky to have, to look at kind of that urban livability, urban space usage of green stormwater infrastructure. The other thing we wanted to get into, and we get into a lot, is people understanding what their impact is on the environment from stormwater, either stormwater coming off the street where their car is parked, or stormwater coming off their own space, whether their house or their apartment building, or their church. We have a lot of places of worship where people have used Rainwise to actually build rain gardens and cisterns at churches and other places of worship. And that's gets it centered in the community, especially some of the multicultural communities where we've been able to get in there and do multiple facilities at different places. We've done some at a mosque, we've done them at different Christian organizations. There's actually we didn't know this until we started working on it, there's actually a green Christian network within the city of Seattle, and I guess nationwide, who's kind of bought into this idea that churches can do this. We've also been working with the Catholic Church for a lot of their properties, and they have a lot of private schools in the area too, where we can do green stormwater infrastructure. So it's been a kind of a wholesale community buy-in. One of the things on eco-literacy is to make sure everybody can understand what you're talking about. So we've been engaged with some nonprofits that work with different cultural groups within the King County region to kind of translate and do trainings and do the announcements about Rainwise in different languages. And right now we have 4 primary languages. We do Spanish, Vietnamese, Cambodian, and name escapes me, but I think it's Amharic outreach, because those areas are eligible for Rainwise. We want to make sure that everybody can understand what we're asking about and what their impact is. So that's what I have for my presentation. Like I said, I want to leave some time for questions, just because I can hear the conversation that I haven't been able to stop behind me, and I want to make sure that people have a chance to ask some questions. I'm happy to go back to slides.
That's okay.
Yeah.
We'll just dive right into them. So Matthew Johnston asked, please explain more about the injection wells for the bioretention cells, dimensions, construction method, cost, etc.
The injection wells are basically built similar to what you would have for a water well, that you bring water up. In this case, we're actually doing the opposite. We're taking water down, but the construction methodology is the same. They drill basically a 3-inch pipe down into the ground. And then we put in a surface facility, which allows us to do maintenance and observation that has a monitoring system on it, like a piezometer that can measure level. They're drilled by a water well. They're a certified water well driller that just happens to go the opposite direction as you would from a water well. They were commonly used in the oil and gas industry for a long time. Portland was probably one of the first cities, Portland, Oregon was one of the first cities to start using it for stormwater, and they have a lot of these injection wells throughout the city. And here in Seattle, we've just agreed to use it for stormwater, but that does need treatment ahead of it. So we do treat the water before it goes into the well. And there's also what you call the Bedos zone, which is the area where you would have no contact with groundwater. The water would go through and get additional treatment. Don't have a handy graphic of what the injection well looks like. We have 2 or 3 different designs we've been using to see which ones are more efficient for cleaning.
Okay. Andrew Wilk asked, would you please re-explain the purpose of the 1.5 milligram mg, I'm not sure if that's the right,
yeah,
gray infrastructure? Does this drain into CSOs? separated sewers, or something entirely different? Is the water completely from runoff or otherwise?
So this, on the right-hand side of this equation, you have the 40 million gallons of stormwater. That's what's being absorbed by the 7.6 acres of rain gardens. So when we put those two items together, that's all runoff. That's from primarily streets. But here in Seattle, a lot of people's standard front yard is grass. So we do get runoff from properties into the street that is also managed. So we have a factor in our design that allows even additional water more than what comes off the impervious street. We have what's called an effective impervious area. So that 40 million gallons would come from that 7.6, from that area that's treated by the 7.6 acres. Kind of a ratio to think about is probably somewhere in the range of 0.3% or so, 3% or so of the acres of the rain garden would be the area managed. So it's probably coming from about a 20-acre area, and that would be the effective impervious. So gives you a sense of how much runoff we get, and that comes from streets, that can come from roofs, and other impervious areas like driveways and things like that. Then we have that 40 million gallons is being absorbed. We can run through a hydraulic model and figure out how much of that actually gives the reduction in control volume. So if this case was a 5 million gallon tank, we reduced it by 1.5 million gallons by managing that 40 million gallons of stormwater on the right-hand side. That 1.5 million gallons of reduction could be a pretty significant amount. If you remember the earlier picture where there was the construction, another 1.5 million gallons there, we may not have been able to build that facility at that particular location, or it would have had to be deeper, which really pushes the cost of excavation up. In this case, we were able to reduce that by 1.5 million gallons to give you a sense of what the direct benefit of using the green infrastructure for CSO gives us.
There were a couple questions about the specs for the rain gardens, and do you have any specs you could share with us, and who's responsible for maintaining the bioretention sites?
The bioretention is built for CSO reduction, which is the stuff King County would build directly. We maintain. We have specifications for design based on City of Seattle Drainage Code, and we actually have a design volume. And if you're interested, I can give the link to Megan, and she can post it as part of this or as part of the video that comes out, because we have it publicly available for that. The other specs for the Rainwise program are actually on the 700milliongallons.org website, and it's under kind of the last tab that says Rainwise. There are actual specifications. These are done by private contractors that are hired by the private property owner directly. They build it, we inspect it, we sign it off on it, and then give them the rebate. So we have specs for both.
Is that a one-time rebate, or is it like every year they get annual rebate, or?
It's 1-year rebate for the construction cost.
Okay.
A large institution or facility would get a reduction in their stormwater fee, and that's an added benefit of getting kind of a larger roof area. Homeowners pay a standard set rate, so they don't really get a reduction, but a large property that pays a stormwater fee would get a reduction in stormwater fee.
Okay. So you answered the who's responsible for maintaining the roadside retention sites. That's you guys. How is
the Rainwise are maintained by the private property owners, and they sign an agreement for a small facility to maintain it for at least 5 years, and then a larger facility would have to maintain it for up to 10 years. And we do go back around and inspect.
So even if it's like in the what we call parking strips here, so that's not their front yard, but if they do it in a parking strip, who's responsible for that?
If it's done in the parking strip, it actually has to be done by King County, because the specs have to meet Seattle Department of Transportation, because they own the road. So it has to be done by an engineer. So it's actually an engineered facility, whereas the rain gardens on private property are more rain gardens. And in Washington State, the difference between a bioretention facility and a rain garden is that the bioretention facility is designed by an engineer.
Okay. Great. How's the square footage of drainage areas confirmed? For example, roof measurements.
We have inspectors that go out and measure the roof area. It's that straightforward. They have a laser measure and then tape. and then they confirm it. Usually they confirm it with Google Earth or the assessor's database, where the county. So we have the assessor's database is open to everyone, so they can go in and actually confirm rough area. So they've done a pretty good job of figuring that out. There's a lot of nuances to that, of course, because not every roof is perfectly square and rectangular, but they're pretty much just measuring the area that drains into a downspout. And then that's how they figure it out. But yeah, it's done in the field, and then it's confirmed kind of back in the office through the assessor's database.
I'm really glad that your talk was so short, because we have about 16 questions and a bunch more coming in. But we have Kathleen Wolf with us, so let me read her question here.
Be Kathy Wolf, huh?
I think so. Let me see here. She came to give a webinar or a talk to, I believe it was her, to Utah State, so I'm excited to have her. So Kathleen says, well, let me ask another question and I'll summarize her question. So Dustin Weberg asked, how much rainwater can be stored on a residential level? I'm not sure what scale, like if he's specifically about a scale or.
Yeah, we can in Washington State, and this is the question sometimes people talk about in the West for water rights. Washington State, we have a waiver up to 3,000 gallons of storage, so they don't have to go through any water rights if you're storing less than 3,000 gallons. Obviously, if you look at the cisterns in this picture, they're anywhere from a couple hundred gallons to 350 gallons. So we're not storing a whole bunch of water on the site. We've seen some big installations that have gotten up to a couple thousand gallons, but we haven't broached the 3,000 gallon yet to see what would happen. But the state of Washington allows us to store up to 3,000 gallons.
Okay. Kathleen asks regarding urban livability. She's seen some large-scale GSI installations that are large parks built around water functions. Example: Portland, Atlanta, DC. What's the role of GSI in placemaking? Are we aware of any specifications that get at GSI and civic space development?
It's starting to catch on. There is in the city of Seattle, there is a requirement to utilize green stormwater infrastructure to the maximum extent feasible in development. So that has happened on individual development. I would say this, as we look into it as an agency, the cost of land in Seattle is so expensive that it would have to be in a park or a space like that where we would actually be able to, it would be cost effective to do so. That being said, most park space is pretty valuable too. So we haven't done a lot of work on putting bioretention into a large park space. However, green infrastructure, just to manage water on park spaces is hit and miss. In other words, we can do stuff like improve riparian zones around small creeks, daylight creeks, which is one of our things we like to look at. In other words, the creek at one point was just piped into the sewer system. Can we get that creek out of the sewer system, use the park to kind of bring back the natural flow of that creek? But as far as, looking at large stormwater facilities, I'd say Seattle, not so much because of our need for land, the condensed space we're working in the cost per square foot. However, within the state of Washington, in Tacoma to our south, they have a stormwater treatment facility at one of their large city parks, and then across the water, when I say across the water, across Puget Sound, on the west side of Puget Sound, there's a municipality that built a stormwater treatment facility near a ferry terminal that they were improving, and quite a large one that can manage a lot of water. So there is kind of that aspect of that. As we progress and look for more space to do this, one of our biggest stormwater management facilities is actually a very popular city lake called Green Lake. It's a large lake that manages some amount of stormwater as well.
Rachel Ormsmith is joining us from South Dakota, and she was curious if you have any colleagues in the Midwest that might be tackling the same issues, or if you could point anybody to any resources that might be located in that area.
I do know some folks in Kansas City who have designed, so Kansas City, Missouri, it's called KCMO. Their water service bureau has designed some pretty large GSI facilities. Laura Ish, Laraisch, is kind of a good person to contact there. And I do know there's some work going on in Denver, but I wouldn't know the contact. the top of my head.
Okay, and I can, I'll put John's email in our chat pod, so if you want to grab it, you can email him directly and get that information. Hillary Sugar asked, she's looking for regional native plant lists for rain gardens that might be tolerant to seasonal flooding and drought. She's in Logan, Utah. So Hillary, I'm going to say that maybe Adria Wheaton could help you with that. I know she's on our webinar here, and maybe I'll email you with some information that I know locally that could help you with that. I believe you already answered this question, who's required to maintain the rain basins in the residential neighborhoods, and that kind of depends on where they're located, correct?
Yeah, property owners are required to maintain their rain garden for a minimum of 5 years.
Okay.
And we've had really good success. If they sell their property, they have to let us know, and they also have to disclose it on their MLS form that says, here's all the things you have to know about my house. I can't remember, I think it's form 17. That has to be disclosed, that the rain garden needs to be maintained. King County, larger, where we have a stormwater in more rural areas, actually has a form to put it on the title itself, that there's a stormwater facility on site. But right now, go ahead.
Why just for 5 years? What happens after 5 years? Is that you expect it's self-sustaining by then, or? It's
self-sustaining. It was something that basically, as we sat down as a group, we thought, what's the longest we could get someone to kind of agree to doing this without actually putting it on the title. We do 5 years for the single family, and then of course 10 years for larger installations. And it's kind of an idea that we went through, and we said, well, what if we lose X amount of rain gardens? How many rain gardens do we need to build? So if a rain garden failed, a lot of these rain gardens don't necessarily fail. The water still goes in and it still infiltrates. It's just the plants may become overgrown. The plants may change out. But most of the ones we've come back and looked at are pretty well maintained. When we've gone into different neighborhoods to kind of get a sense of how they're doing that, and we assess that every couple of years. But so far, so good. I mean, we've seen most people maintain these. What we have seen is houses that are sold and the homeowner didn't know about it or wasn't disclosed. That's why we do the MLS 14. Someone might actually go in and fill in the rain garden, at which point we will ask questions.
Yeah.
There's not much we can really legally do, but we can at least ask or identify it. But we do like to let new homeowners know what the purpose of that facility is.
I think a lot of homeowners are pretty happy with low maintenance things that might,
yes,
not require a whole lot of hands-on work. Right. Somebody asked, are there any stormwater bump outs installed on streets with high pollutant load? And if so, what specific pre-treatment methods have been successful?
I'm going to go back to this slide. I think this is a bump out. This is a residential street. There are some facilities here in Seattle that are built on arterial streets, but basically what you have is what we call a sacrificial cell that will take on any of mainly the sediment that comes off the road. So this cell over the years would probably lose some of its infiltration capacity because it starts getting quote unquote clogged with sediment. There are also additional studies going on looking at copper and zinc uptake, and what we actually found was there are some composted soils that have more copper and zinc than the actual road. So we've been working on the specification for composted soil and the level of copper and zinc in composted soil. So we don't see a lot of those pollutants coming directly from the street as much as it's already embedded in the system. And then we also see is a lot of these plants, and a good diverse plant palette will give you some uptake of some of those quote unquote pollutants. The main pollutant, without a doubt, that has the biggest impact is just the sediment loading from the streets. And that's why we have to kind of design that into this more sacrificial cell.
And some people were asking about, Robert, recommended plant lists. I assume you probably only know those for the Pacific Northwest, but is there a place you can direct folks on your website?
Yeah, the 700milliongallons.org and the design manuals, which I'll send you the link for, both have kind of plant palettes with what's recommended here in the Pacific Northwest. The Washington State Extension Service has a really good plant list for rain gardens. Usually what I've found is extension services, and I'll put a plug in for them, have good plant lists for rain gardens. because they know what grows well, what's native, and what level of watering they need. If you notice in this picture on the left, those plants kind of at the bottom are wet throughout the winter, and the plants kind of up on the slopes are damp, and then very dry in the summertime around here.
Thank you for plugging extension. I think a lot of people don't know a lot about extension, and that's part of what I do. And so, yes, thank you very much. Eric asked, is tree canopy cover a viable practice for rebates in the Rainwise rebate program? If so, do you have a number? For example, how much cover gives how much of a rebate?
It's not part of the rebate program because of the maturity time of planting trees, although we encourage the tree planting. For the stormwater code in Seattle, tree cover is a credit towards Green Stormwater Infrastructure to the maximum extent feasible, and they have a calculator online that gives the credit for number of trees planted on a site.
How should GSI programs be approached differently in the Midwest, where rain events with high peak flows are more common than the kind of peak flow events that you experience in the Pacific Northwest?
I am a Pacific Northwest person and understand that. I do know the rain timing is different. One recommendation I would do is to look at some of the cities that have implemented large green stormwater infrastructure and see what they're doing for what their peak flow might look like. And that would be Kansas City. I know has probably the most mature program that I've seen. And I don't know more than that. And I would say the best thing to do is do some hydrologic and hydraulic modeling to kind of, on a small scale, to kind of figure out how those peak flows impact the green stormwater infrastructure and, of course, your downstream hydraulics.
Megan asked, how much relative cost do the injection wells add to the GSI project costs?
They run generally about $10,000 to $15,000 more, depending on the depth. If you do a number of them, obviously they add to the total project cost more than just the bioretention. But the bioretention, the street work, and all that kind of mask that cost for the injection well. And it depends on how deep you want to go and how fancy you want to get with the infiltration structure around the well. Those can all add on the cost. The ones we did for this project were averaging about $12,000 each.
A fair amount of questions about the maintenance issues. Who selects the plants, maintains the gardens? You've identified who does the maintenance. I assume you had Extension help you with plant selection.
We had a pretty good palette to start with because our landscape architects had designed enough of these facilities to know what works, what doesn't. The other arm of that, as you select plants, is to work with the maintenance staff that's going to maintain them, the people that are actually out there in the field maintaining them, what experience they have maintaining, and they help you a lot, saying, no, we don't like that because we can't weed underneath it. We don't like that because it grows kind of wild and it has to be pruned a lot. So it is a kind of a partnership between the design team and the maintenance team to sit down and go through the plant palette before you even get out to the community and say, what do you guys want to see in these? This is, as you can see from these pictures, it's right in people's front yards. And we want to make sure they're happy with what's selected. So there is choices of plant palettes, although limited, based on what we know from the design team, based on what we know from the maintenance team. And as we build these and have different people out maintaining, we learn, that plant just doesn't work. Let's not put that one in the next facility we build. When we built this project, we built it in phases. So we went from basically opening up the street, building the facility to a complete facility, and then per block. So each block came online as we didn't build we didn't just dig a whole bunch of holes, then come out and replant. We built, planted, and operated, and built, planted, operated each block. So we would start getting a sense of how things were working. We actually made adjustments because we used 2 seasons to do that. That in the second season ones, we took a few plants out because they already had kind of started taking over the rain garden. Don't ask me the specific plant because I'm not a plant person, but there were some small, what would be called small shrubs that became basically large trees with this type of environment to grow on, which is really rich soil and lots of water, and they took off. And it was like, okay, let's not put those in a rain garden again, because they grew more than what the books tell you they'll grow.
Yeah.
So that was kind of learned by experience, and it's going to depend on where you are. In this particular neighborhood in Seattle, we get the plants growing that way. We can go 5 miles to the north to a different neighborhood where they've done it. The plants grow totally different. I mean, we have so many microclimates in Seattle that kind of things grow differently even within the city itself. So we're very, it's a trial and error. And if you need to pull a plant out, you need to pull a plant out. You can always replace it with something that works better. And we do recycle a lot of these plants. In other words, take them out of this one facility and use them in a different facility because they won't grow as big.
Any thoughts on the using biochar as a filtration tool?
I have not seen the final report, but our Washington State University and a few others are looking at biochar as part of the compost mix or the bioretention soil mix. And I've heard some good things about it. That's about all I've heard. I don't have any exact numbers or how much pollutant it uptakes, anything like that. But it's supposed to be very good with the nutrients that come out of rain gardens because of the compost and things like that. It's supposed to be filtering some of the nutrients out. That's one thing I've heard is a plus for biochar, but I haven't seen any. The papers haven't been completed or released publicly for us to see that kind of research is being done.
Great. Any mosquito or black fly issues with the standing water in your stormwater?
So we get away from the mosquitoes by making sure these things drain. So the requirement in Seattle is they drain within 24 hours, which in the wintertime here does not allow for the mosquitoes to grow, the larvae to actually get planted in there. In the wintertime, we don't have problems with mosquito larvae. They don't start coming about until May or June, when our rains start to kind of diminish a little bit. And the smaller rains we get in the summer and winter are infiltrated very quickly because everything's pretty much drying out by that point. So that's a requirement. Now I know mosquitoes and other vectors are a huge issue in other places where they've had to be more creative in what they do. But the 24-hour drain period should just about anywhere keep mosquitoes from actually starting to hatch larvae. And of course, dragonflies are the best thing to have around too. So.
Zachary asked, are program participants able to hire any contractor they wish as long as the garden passes inspection, or is there some sort of network of pre-approved contractors? And how is the maintenance going? Any sort of initial observations?
Maintenance on the private ones, it seems to be going, it's hit or miss. If you look at a well manicured lawn and yard, like you see in the right-hand picture, the rain garden in there is well maintained. And I will say there are some that are, they're maintained. The homeowner can contract with a Rainwise certified contractor. So twice a year we hold a workshop. It's 2 evenings and then 1 Saturday for the contractor to get the Rainwise training. And basically it's going around showing them different things, talking to the inspectors on site to kind of give like, these are the things you do. The largest part of the training really is around the rainwater harvesting systems, because very specific draining requirements on those to meet the CSO benefit. But we do have a list of about 100 contractors that have been trained, and a private property owner can contact anyone on the list that's been trained to come in and build the rain garden for them. So they have some flexibility and some choice. It's quite a few landscapers. However, as we've been looking at the information, we basically have about 5 or 6 out of the 100 that do multiple rain gardens and seem to be catching on. So the one thing we've learned is it's actually more word of mouth that gets the contractors hired versus people going to the website and looking for a specific contractor. So their neighbor got one installed and the person liked it, so they called their that same contractor.
Zach was wondering, he's in Philadelphia, where their rainwater, where their similar program is called Rain Check. Do you have any sort of nuggets of wisdom or things that, in terms of marketing, that might help the program expand? Maybe that's not your area of expertise. But.
Well, actually, the outreach folks come to me all the time, going, "We need to do this. So I do. So one thing I would say is a big one for us was we're at a point now where we've kind of maximized the use of the contractors. In other words, there's more projects out there than there are contractors. So we haven't expanded by where we are now, which is about 45,000 properties eligible right now. we're kind of hesitant to expand because the contractors are saturated with work. So we're trying to get more contractors in, and so what we're doing is a series of workshops with the contractors that may have done one and not done more than one, to kind of get some information from them on why did you just do one and then not do any more in the program, to see what barriers are to the program. One is there's a sense of when the homeowner contacts the contractor comes out and wants to charge for an initial site inspection, and they usually charge about $150 to $200 to do initial site inspection. Well, that's kind of a barrier to people getting into it. Some people don't want to take that risk if the answer is no. So that's the thing, that contractors have to have enough capital in their bank account to kind of go out and maybe absorb some costs up front before the rebate comes in. So that's kind of a barrier that we have to figure out how to get around. The other thing we see as far as outreach, it's, we can send out a postcard to every individual house that's built, but not everybody reads it. We do a lot of outreach at community events where people are going. So we're popular at the farmers market in the springtime, letting people know that they're eligible. We have not yet actually gone door to door, but we do send out a postcard. I would say a lot of people are disappointed because they can't have a rain garden and they have to install cisterns. So they may say, well, I don't want a cistern, I wanted a rain garden. And it's just not feasible to put a rain garden in our yard for a number of reasons. A lot of steep slopes here in Seattle, which we want to keep rain gardens away from. And then also bad soil. The soil is just not good enough for the infiltration. We also have a lot of houses that have a negative slope, we found. And that was kind of interesting. As the contractors go out, there's they can't actually find a way to drain the rain garden towards the street because the yard sloped. So there's a lot of little factors like that we've been trying to deal with that just kind of stop people from actually participating in the program. And then it's really just getting the word out. And we don't do a lot of television or radio advertising, but what we do try to do is get the news channels to cover kind of the big installations if we do it at a church or a mosque or something like that. So then the word gets out about that. And I've gone out and done a program with our local eco-consumer on a news channel, but we don't see a significant boost because we went to traditional TV, I guess. Don't see a significant boost in participation from that. So, we're always looking for that way to get in there and find the people that, most of the people that do this are on some sort of green network, or, they're friends with Nature Conservancy staff that are doing this, our stewardship partners. We have about 6 nonprofits that help us with outreach as well, to kind of get the word out. But I would say we've saturated the program because, like I said, we only have so many inspectors and so many contractors. If we could increase the number of contractors, obviously the increasing number of inspectors is on us, we could probably feel more comfortable expanding it more than it is now. So there's a lot of different factors, but the outreach is a constant and ongoing thing. And I'd say about 30% of the overall program cost goes into the outreach. So
great. I'm going to launch the poll right now, and we're going to keep answering questions if that's okay with you until the end of the hour, John. So
sure.
I'm going to put the poll up, but you could leave your screen on however you want, John, and we will. People can just move the poll to the side of their screen so they can stay engaged. So Elena's mentioned that they're doing similar projects in Columbus, Ohio. So if you feel inclined, Elena, feel free to put your email address in the chat pod so folks can email you directly if you're up for that. Let's see. Are there programs in place to monitor the changes in water quality within streams due to the GSI? Have there been some significant improvements since the start of the project? So a lot of people were asking about sort of who's doing the monitoring and how's it going?
So unfortunately, we were doing this for CSO control, for combined sewer overflow. So none of the facilities we manage directly discharge to a stream. What we monitor is inflow, and then outflow, and then what's happening at our combined sewer overflow facility. City of Seattle, I believe City of Bellingham here in Washington, a number of other cities are doing it for improvement of stream water quality, and they've been releasing information on how these impact streams and stream water quality. So I probably hear about it, but I'm not an expert. So, in a national webinar, I would direct you to the City of Seattle to ask that question. And I can, if people are so inclined, they can email me and ask for the person at the City of Seattle that might have that information. We do post a lot of information about that, but so does the Washington State Extension Service has a very good, which has now been called the Washington Stormwater Center, has a lot of information on studies that have been done on creeks and the impact of green infrastructure on creeks. And that's Washington Stormwater Center. If you Google it, you can get right to their website. The LID Center in Washington, D.C. also has been doing a lot of work on stormwater and creeks.
LID, low impact design, I learned that.
Low impact development center.
Yeah, or development, okay. What's the maintenance plan for the sacrificial cells? Is it different than the other areas?
Typically they go in and they clean out sediment as they see it, but we put a rock line at the bottom to kind of not make it look like a little sediment trap. It looks a little bit nicer. I think if the water wasn't in any of these cells, you see there's a little rock line under it. Normally what they do is they can rake, scrape, or dig out the sediment as it builds up. But it's kind of interesting. We figured there'd be a lot of sediment loading when we designed these, but we haven't seen the sediment loading we were expecting. We're just going to keep an eye on it. And if the maintenance folks feel like they need to dig it out, then that's probably another 5 or 6 years down the road, we would dig out the bottom and replace some of the bioretention soil that got clogged. But so far, it's looking pretty good. So, again, is that because we're telling people that this facility is managing stormwater off the street, and are they keeping the street a little bit cleaner? Or is it just, by happen circumstances, we pick streets with not a lot of sediment on them? So I can't really tell you if we're going to do anything different. We do have a process and a procedure to keep an eye on it.
So I think that answered Ethan's question. He asked about how to keep drains or wells clean and not clogged with organic matter. And did you make any changes over time as you sort of understood the challenges that came with that, or have you pretty much stayed consistent?
Yeah, so what we did to keep the nutrients out was we actually, what we called the commissioning stage of the bioretention facilities is we blocked off the UIC wells for 70 days and then 100 days. So in other words, we could water them because we had irrigation, irrigation facilities inside it. We could water them in what I would call saturate the bioretention soil and move the nutrients off. They went into a manhole that was just before the UIC well, and that would fill with the sediment, and then we just factor that out. And we did that for 70 days on some and 100 days on other. We found the 100 days, the amount of organics building up on the UIC well screen was reduced. So we think the commissioning period is about 100 days. Run the facility with the irrigation water, flush out the nutrients, and then once the plants kind of stabilize, those nutrients start getting taken up, and then there's less nutrients going to the UIC well. So once we've gone through the commissioning period, a few of our UIC wells need to be cleaned. So we did a cleaning process where we cleaned them and they stayed clean, but it was the ones we had a shorter commissioning time for. So we developed a commissioning standard for them. If you don't have the UIC wells, it's not an issue because most of the under-drained facilities go back into the combined sewer system. And then there are some fairly specific things we're looking at for direct discharge to streams. But again, I'm looking more at the CSO side for when it comes to streams. I would say the Washington State Extension Service has the most up-to-date information on what kind of nutrient loading you get from a bioretention. But we did a lot of work on the commissioning time to kind of figure out the right time period to kind of reduce the chance of clogging streams on the UIC well.
A couple more minutes left. Are the cisterns stored water used for landscape irrigation or brought inside and used as gray water?
Only used for landscape irrigation. We're working with public health on gray water use in private homes.
I think you mentioned something about heavy metals. Is there any monitoring sampling of metals in the outflows of rain gardens? If yes, how extensive are heavy metals in these systems? I'm sorry if you already answered that.
We have, there has been some studies, not on the particular cells, bioretention facilities that I'm working with, although some folks are getting together a study to look at the water quality coming out of these. We didn't specifically have to look at the water quality. The treatment process was basically presumptive as far as the UIC well. There are copper and zinc issues on some of our bioretention here in the Northwest. So there are some extensive monitoring being done with the directly discharged near streams. But as people want to study more bioretention, the facilities are set up for that. I know there's been some studies out of Redmond, Washington, and Bellingham that talk a little bit about that.
How did the public initially respond to the conversion of Parkway turf to rain gardens?
Most were open to the idea. We had a few people that didn't, were kind of hesitant to accept them. Once we started walking through, one of the things we did was kind of interesting. We spent a couple Saturdays just going out, putting down tarps, showing them pictures of what they could look like, and then just kind of, for people to understand how they kind of fit into their neighborhood. The response once they were constructed and during construction was really good. We accepted them, they understood it. They got out of having to mow them. So I think that was a big plus. Because they usually, if we don't plant anything, and if we don't do a bioretention facility, the homeowner maintains the planting strip. So now all these planting strips are maintained by the county. That was a plus. I think people have small specific things like, could you put a little bit more gravel up front by the curb because I parked my car, I want a place to step. Those little things, it's easy to accommodate. But then we also started thinking about those in future designs as well to kind of make it a little bit more palatable to the community. But we had a fairly good response. At first, people were very hesitant, but as time went on, they understood them and then became more accepting. As of right now, we actually have our phone number on the curb every so often, so people can call and say.
That's great.
Little placards that can be fixed to the curb, because all our facilities have to have that. It was actually a requirement, and this is it's not a traditional wastewater facility, but it's a facility owned and maintained by King County, so it needed a point of contact. So we have that, and every once in a while someone will call and say, hey, I noticed something. I noticed garbage in it, and we say, great, get a grabber and pick it up. But they stay fairly clean.
Awesome. Well, I think that's a great place to end, John. I think we got through most of our questions. I apologize if there were some questions that didn't get addressed. I have kept a running list of things that John has said we will get out to all of you. So keep your eye out for an email from us, and we will make sure that some questions get answered and some contacts get shared as far as Elena in Columbus, and we had another person offer to give some information to folks for a similar rain check program in Philadelphia. So thanks again for joining us today. Thank you to John. I really appreciate everybody tuning in today. Please take the poll quickly before you exit our meeting room, and stay tuned for another great year of Learn at Lunch webinars, if I do say so myself. And yeah, thanks everybody. Have a wonderful afternoon and Happy New Year. Thanks, Mark. Thanks, John.
Thank you.
Okay.